Friends, welcome to my YouTube channel. Today I am going to discuss the support reactions for problem. So what is the problems given here? They are asking calculate the reactions R1, R2, R3. The beams AB and CD, AB and CD, two beams either are connected with the hinge connecting B and C. This B and C, they are connecting hinge. So like this problems now directly we cannot solve. So we have to solve two steps. So first steps what we have to do? We have to take the CD. Beam CD we have to take separately. And they're asking here hinge. Hinge always will be the vertical reaction connecting. So I wrote considering the equilibrium of beam CD, hinge at C offers a vertical reaction RC. So in this point, vertical C points will offer the vertical reactions RC. And as it is C, 16 kN load is there, and D, R3 is reaction at point D. So first we'll solve this. After solving this, we'll get the RC. Then we'll another B will find the solution for that. So now what we had in the first steps, we taken CD here. RC already I wrote here, considering the equilibrium of the beam CD, hinge at C offers a vertical reaction RC. So now we'll find the support reactions here. So as usual we know how to find the support reactions. We have to find the two equilibrium equations. Sigma F equal to 0, first equilibrium equation. That means total upward force equal to total downward force. So what is upward force here? As you know, RC plus R3. Then downward force what is 16. If you will give equation number 1. Now we'll take the moment about C. Moment about C equal to 0. That means total clockwise is equal to total anti-clockwise moment I will take. So C point moment. So what is the clockwise moment here? If you will see, this is the clockwise. And this will be the anti-clockwise moment. So clockwise moment is 16 into total distance 3. So what is there here? 16 into total distance 3. Then anti-clockwise is equal to R3. R3 into total distance 4. So that way we can find out here R3 equal to so 48 by 4. So 12 kilonewton. I know the R3 12 kilonewton. Then if you substitute this equation 1, so you will get RC here. Substituting equation 1, we are getting RC. How much? 16 minus 12. 16 minus 12 equal to 4 kilonewton. So RC, now we know the 4 kilonewtons. Okay. So now what we have to do here? Another beam already drawn. So I wrote here what is for the equilibrium conditions of hinge connecting at B and C, this point, connecting B and C, there must be two equal and opposite reaction. Because this is hinge, so equal and opposite reactions to satisfy the total vertical force equal to 0, sigma F equal to 0 at hinge. So what we have to do here? Local, so load. So load acting RC will be the downward at B. So load acting RC at downward at B. So I shown here. Now step 1 is over. This is the step 1. We got it. Now steps 2 what we have to take. Step 2. We draw this beam. As it is 4 kilonewton 1 meter, 16 kilonewton 3 meter. This is 1 meter 2 meter, and then R1 R2 support reactions 4 meter, and this is 1 meter gap. And C, as I wrote here, hinge at downward direction. Now we will find the support reactions here R1 and R2. So again we will take the two equilibrium equation. What is sigma F equal to 0? Here again we will take what is, as usual I am taking, we are not taking negative and positive. So we are taking what is total upward force equal to total downward force. Now what is upward force? R1 plus R2. R1 plus R2 is equal to downward force what is? 4 plus 6 plus again 4. So this is the 14 kilonewton. So 14 kilometer, give equations number 2 here. So we got the 14 kilometer equation number 2 here. Now we'll take the moment about R1. So we'll take moment about R1. So what we'll do, you give this point E. So name I not can, so we give this point E. This point I am giving E. So we'll take the moment about E equal to 0. So here also total clockwise, you can write it like this. Total clockwise is equal to total anti-clockwise moment. So now what is R1? Take the moment. So now we'll see the rotations. If this will rotate, this is coming ACW. This is coming rotation clockwise. This is rotation ACW. And this is rotation clockwise. So how many clockwise? This and this. So this, what is clockwise? 6 into total distance 2. This is 1 or 2. So 6 into 2, 1 rotation clockwise. Then next clockwise will be 4 into plus 4 into total distance. How much? 4 plus 1, 5. Total distance this equal to anti-clockwise 4 into 1. 4 into 1. Then R2 plus R2 into total distance is R1 to R2 4. R2 into 4. So this way we can calculate the here R2. 12 plus 20 is equal to 4 plus 4 R2. So 32 minus 4 is equal to 4 R2. So here how much? 28 by 4. This is R2. 7 kilonewtons came here. Now you substitute this R2. Substitute R2 in equation 2. In equation 2. So what we'll get here? R1 plus 7 equal to 14. So that implies R1 is equal to 7 kilonewton. So what they're asking here, find the reactions R1, R2, R3. So we got the here R3. So we'll highlight this. We know the R3 how much here? R3 12 kilonewton. R2 we know the 7 kilonewton. And R1 we got the 7 kilonewton. So we'll check it this. So this beam AB. So now look here what we did. They're asking find the reactions R1, R2, R3. So two beam will be there. One in point B, one connected, hinge connected C and D. So what we did, first we taken this beam here. First we taken beam there, then find the support reactions both RC and R3. We got the R3 here. Again R3 at vertical downward direction. So again we taken beam AB. This beam AB we taken here. And we find the support reactions R1 and R2. So both reactions R1, R2, R3. This way we can solve these problems. Okay. So these questions and all they will ask in GATE questions also. They will ask suppose only one choice. What is the R2? Then also you have to know the concept this. Okay. So okay, friends, watch this video. Share this video to your friends so they can get the maximum benefits. Okay. Thank you.